So let us just have a look at the sea surface temperature during these events. Okay. And the sea surface temperature distributions are shown on the top two. Look at panel B. This is actually how the sea surface temperature looks like. Eastern intertropical Indian Ocean. So you're in the eastern bit. This is Sumatra. No, here the mouse doesn't work. So here, this is Sumatra, and this is Java. Okay. So equator is also shown here, and that's 10 degrees south. Right. So in most years, and this is in 9 out of 10 years, you can see that there's a weak indication of upwelling along Java. Okay, well, how can I tell you? Because it's a little bit colder. So, there is no sink of temperature anywhere in the ocean interior. So the only thing that can do that is the upwelling of colder water to the surface. So you learned all. It's easy, isn't it? Okay? But in some years, and this is during these positive IOD events, you get strong upwelling. Okay, you get strong upwelling. The Java upwelling intensifies, and you get upwelling in this part of the Sumatra, along the Sumatran coast. Okay. So what happens if you now look at the difference, you can see it. You actually during these events you get a massive cooling of surface waters in a relatively large region. This is the difference. The difference between the panel A minus panel B. It's the difference. And again, with your knowledge about tropical convection, you straight away see that this has an influence on tropical convection. If you cool down the sea surface, it actually weakens the tropical convection. Okay, it can suppress tropical convection, cloud formation, influences rainfall. Okay? This is what we call the Indian Ocean dipole. All right. Indeed, the events that have this strong upwelling have an influence on the marine ecosystem. Okay, but it doesn't. These events are relatively rare. The positive Indian Ocean dipole events, and we don't know much about the fisheries and the marine food chain dynamics in these areas.